There's a few different forms of quadratic functions. Do you guys know what the other forms are called? Okay, one of them is standard form. Another one is what? Factored form. Each form has like its pros and cons, right? So with vertex form, which is a new form that you guys will learn, that one also has pros and cons. So the vertex form of a quadratic equation, you can fill this in, y equals a parentheses x minus h close parentheses squared plus k. All right, y equals a parentheses x minus h close parentheses squared plus k. So with this form, one of its pros is that you can clearly see the vertex. Okay, I'm not sure if you remember what vertex is. We do talk about it more in algebra today, but it's like the turning point of that U-shaped graph. So in this form, the numbers in the H and the K position are going to be your vertex. And X equals whatever numbers in the H position will be your axis of symmetry. So in standard form, you have to like make a table, graph it, and then find those things. In factored form, you have to convert it to standard form and then find those things after you graph it. This way you could see it just from the equation. So it's kind of nice. And if you want to draw this like to the side in this free space, just so that we know what a vertex is. Okay, vertex is the turning point of the graph. The graph can either open upward or downward, so vertex would be the turning point. And then what do you think the axis of symmetry would be? Nothing? What does it mean if something's symmetrical? It looks the same on both sides. It looks like a reflection of each other. So the axis of symmetry is kind of like an imaginary line down the middle that splits it into its two parts, okay? So the reason why that could be important is because you could graph it from that way. All right. So then for the first problem, it's given to me in vertex form. It wants me to identify my axis of symmetry and vertex. Well, based on my formula here, that should be really easy. So my axis of symmetry is always going to start with x equals. All right, because it's supposed to be an equation of a vertical line. So that would be x equals, not y equals. That part would be the same. It's going to try and trick you like that on your unit test. I'm telling you now, it has to start with x equals. All right, and then whatever number is in the H position is your axis of symmetry. But notice H is in the parentheses with the x, and it has it as negative. Okay, so like in number 1, for example, it says +4. What would I need to enter into this equation to make it turn into a positive? Is my x going to be 4? What is it? Because if I plugged in a 4, then it would look like x minus 4, and it looks like x plus 4. So what would I have to plug in to make it turn to a plus? Feel like someone else. So again, if I plug in a positive 4, then it would look like this in my formula, x minus 4, but it doesn't. It became plus. So that means I would have had to plug in a negative 4, right? Because then it would have looked like this, x minus a negative 4, and that double negative turns into a positive. So always remember that. In the normal formula, it's x minus h. So if it became positive, that means I must have plugged in a negative number. So it's kind of like the opposite of how it looks in the problem. So then let's look at number 2, for example. What did they plug in to make it look like that? A positive 3. Even try it. Try plugging it in. So minus 3. At least that's how it looks. Okay, question? So what did they plug into here for my axis of symmetry? A positive 5. What would be my axis of symmetry in number 4? Right, there was 1 vote for positive 2. Why is that one more difficult? It doesn't, there's no parentheses. So the rule for the axis of symmetry for the H is it has to be in the parentheses with the X. If there's nothing there, what must have been plugged in? If it just ended up being X in there. Nope, because then it would be X minus 2. What would I have had to plug into the parentheses for H to make it just become X alone? Not 1, because then it'd be X minus 1. 0. Right? Because anything minus 0 is just that number, right? So that means that my H must be 0 if there's no parentheses anymore and the X is alone. Make sense? So the number in front of the X has nothing to do with axis of symmetry. All right, the number in front of the X is an A, which does other things to it, but not anything with the H. Questions on that? All right, and because previously, and again, the order that it teaches you stuff in the algebra curriculum is kind of weird, but previously you would have had to use this axis of symmetry formula, which is x equals negative b over 2a, and that you would need it to be in standard form for. But when it's in vertex form, you just look for the number in the H. Questions on that? Okay. What exactly? Like what part? Like how you know what number goes here? Yeah. So you look at the equation. So this is the variables for the equation. The A, the H, and the K would all be normally replaced with numbers. All right, so if you're given an equation in this format, you just have to check what number is in the parentheses with the X, and that's your axis of symmetry. However, you have to also pay attention to the sign. So in the formula, it has it as minus. So if whatever number I say is the axis of symmetry, has to make sense when I plug it into the formula. Like if I said it was 4, that wouldn't be right because then it'd be x minus 4. But here it says plus 4, right? So then that means I must have plugged in a -4, which then makes it positive. Okay, so the H is always like the opposite sign of how it looks as a problem. Okay, questions? All right, so let me show you just one more thing. So you can also graph these in Desmos as well to kind of like verify. Okay, so I'll type the first one in. All right, and our task is to find the axis of symmetry, which is that imaginary line that goes down the middle and makes it symmetrical. Well, like what we said it was is x equals -4. Does that go down the middle of this U shape? So that's the way you could check your answer. If I just type in x equals 4, it's like way over here and not making it symmetrical. Make sense? So that is why the x equals matters. Because if you put y equals, now that's a whole different line. So it has to be the equation of a line that goes down the middle. Questions? Okay, now the next part is the vertex, which you could graph and, hover over the turning point of the U shape. Or you don't even need to graph it because you know vertex form, or at least you will after this lesson. So for the vertex, we're saying HK is the vertex. So we already know what H is in number 1. What was my H? Table 1, what was my H in number 1? I just already know whatever we put the reaction. Negative. We already went through how to find it in the formula. Make sense? Okay. So -4 is my H of this problem. What number is in the K position? And this number 1 is -2. All right, it's whatever number is outside the parentheses, either being added or subtracted to the problem. Okay, not multiplied like the A is. Okay, just whatever is being added or subtracted outside of the parentheses. And that one's easy. That one matches the sign that it looks like in the problem. So H is always opposite. K is always the same as what's in the problem. So then, knowing that now, you guys fill in the vertex for these other 3. Okay? All right, table 2, what's my vertex for number 2? Sorry, what'd you say? Class, agree, disagree? Is there a -1 out here? No, there is a -1 being multiplied, but that would be the A, not the K. So then my K is actually 0. And that's why there's nothing here, because you don't usually write the +0. Make sense? Okay. Common mistakes. That's why these are the examples, because these are common mistakes people make. What about the so table 4, what about the vertex for number 3? 5, -4. Agree, disagree? Okay, good. And the K is easy. It matches how it looks in the problem. The H always has the opposite sign. That's how it looks in the problem. All right. Table 5. What about the vertex for number 4? 0, 3. Question? Comment? All right. The K is whatever is being added or subtracted to the problem. Not multiplied. Good. Just moving down. We are going to graph it. Do you guys remember how to make a table? For any function, no matter what the equation is. How do you determine what your x's will be? Do you get to pick your x's? Usually, yeah, you get to pick your x's. For these U-shaped graphs, you want them to be near wherever the middle of your graph is, right? So in other words, your axis of symmetry is probably a good start for what x's you should pick for your problem. All right, but you should all be able to identify axis of symmetry now based on how it looks, because it's in vertex form. That makes it easy. So for this number 5, identify your axis of symmetry and vertex real quick, just on your finger. All right, so axis of symmetry, let me ask table 6. Axis of symmetry is what? That's 2? X equals 2, you said? Okay, so good on the x equals. That should always be in all your axis of symmetries. Is it 2? -2. So the H is always in the parentheses with the X, but it's always like opposite sign. Okay, so if it looks positive here, make sure it's negative for your vertex and axis. So then that's my X of my vertex, right? So that's the X value. What's the Y of my vertex? Then +7. Just however it looks. So you can think of it like +K, -H, like maybe that'll help you remember to flip the sign. I don't know. Because if you add a negative number, like you just put the negative number in there. I don't know. Whatever helps. But that's where you look. Questions on that? All right, so for these, to make your table, put your vertex in the middle row. That way, you can pick some X values before the middle and after the middle. That would be the best way to see that U shape. So what are some numbers before -2? -3 and -4. What are some numbers after -2? And 0. Good. Do you know how to find Y? Well, since we have x's now, we just plug them into the problem. So, like for the first x, and anytime you plug something in, use parentheses, I'm plugging in a -4 into the given problem. This whole thing I can put into my calculator at the same time, and then just let it do the order of operations for me. Okay, so that's what I'm going to do with Desmos. Okay, so negative parentheses, whatever you plug in, just put it in parentheses. That's a good habit. So everyone see how all I did was replace this X. It's the same equation. Then that means my first Y value is 3. And you put that in your table. And really from there, all you are changing is the X. So what's my next X? So change it. My next y is 6. All right, we already have the vertex, but if you wanted to check anyway for some reason, all right, you do get 7 for that middle one. Then my next x after that is -1. We get a +6. And then my other x is 0. And I get a +3. And if you notice, they start to like reflect each other. That's a good sign. That means it's going to make a U shape. So that's what I'm going to graph next. Tiara, did you need something? You'll be after Zen. All right, but now transfer it onto your coordinate plane. Hopefully you guys know that, how to do that. If not, help each other. And what I end up with is this U-shaped graph. And it goes on infinitely unless it says otherwise. Questions? All right, do we remember domain and range? That's another one of those things that I told you would show up over and over again. And we've done actually domain and range for parabolas before. That's the U shape. You just might not know it. So domain is referring to all the what? X's. Will this eventually touch all the X's? Well, think about it. As it's going down, is it getting wider each time? So eventually it will. So when it goes infinitely left and right, my domain is going to be all real numbers. And there's only 2 ways that these parabolas can go, either downward or upward. Whatever way, it'll eventually touch all the X's because they get wider. So if you want to remember for this unit, the domain will always be all real numbers. Go ahead. The range refers to all the what in a problem? All the y's. So look up and down, because that's how the y-axis goes. Does it go infinitely up? No, so that means we're going to have a boundary. And because it's a continuous graph, we're going to use an inequality. What number does it look like it stops at? 7. And that should match the y value of my vertex, because your vertex is always like your highest or lowest point. So there you go. Would you say that the y values that are in this table or on this line, would you say that they're greater or less than 7? Less than, like here's 0, that it'll eventually touch. That's less than 7. 6 is less than 7. So put less than. Does it touch the 7? So put the equal to part. So the graph does not go infinitely up. So we show this to say like where it stops at. Does it go infinitely down? So then I do not need to put anything over here because it goes infinitely that way. Questions? I guess if they did anything, you could say that it goes to negative infinity. But if I remember correctly on your test, it just shows it the normal way. Questions? All right. Do you think you could try one from scratch? Like number 6. Okay, try it. If you need help, please ask. Please, I will help you. I will guide you there. I might not directly tell you the answer, but I will tell you how to get there. So number 6, try from scratch. Start with your axis of symmetry and vertex. Then make your table, graph, answer all the stuff. Okay, just checking in because I don't want you to get too far if you are incorrect. What's my axis of symmetry for number 6? X equals what? 1. All right, anyone think it should be a -1? Okay, it's a positive one, so you guys are right. So yeah, if it's a positive one, remember this is our vertex form, the same formula that you wrote up top. If like you need to actually plug it in to see if it looks like that in the formula, then do so. But the number that's with the X in the parentheses is your H, and it has the opposite sign of how it looks in the equation, okay? So then my X of my vertex should then be what? Oh. +1, because it should match the H of my axis of symmetry. And then my Y of my vertex in this problem is what? 0, because there's nothing being added or subtracted over here. It's not the 3, because that's multiplying. Okay, so 0. So now that you have this correct, fix either whatever you proceeded on to. But this vertex should always go like for the middle of your table. Okay, now fill in the rest. All right, so the way that you should be making your table for these is to kind of form it around your vertex. You want to make a U shape so it makes sense to have it be like around the middle. So Sam, looking at my table, my vertex is in the middle already. What number should I put before the 1? Well, what are some numbers that are around 1? 3. Okay. What else? Okay. 4. And there are in the left side. Okay, good. So that's how you should be picking your X's. You get to pick the X's, but you should form it based on your vertex. Yeah, because for these, but you're picking it based on the vertex. Because you're going to want it to make a U shape, and the only way to do that is to find the middle of your U, which is your vertex, and pick numbers, X's that are around it. Isabel? After Elise. So, yeah, so you pick the X's. The Y's, you can only figure out those by plugging them into the given formula. So do that. This is what it might look like in your calculator. Because you don't have to do these by hand. In fact, I recommend that you don't. So it's easy to make a silly mistake. But really just what is to the right of the Y, you're plugging into your calculator. So everyone see how we just plugged in the first X? All right, so do that. Sorry, I don't know these off the top of my head, so. 3 parentheses, anytime you plug stuff in, use parentheses. So my first Y value should be 12. What should my second Y value be? Mia, what should my second Y value be? No. Oh, you're talking about Y. Yeah. Zen, what is it? All right, it is 3. So you're plugging in the X's to get your Y. I already have my vertex, so I don't need to necessarily plug in the 1. All right, plug in 2, we also get 3. Plug in 3, we also get 12. So when it like starts to repeat the numbers in this like fashion, that's a good sign. That means you made a U shape. And also you can kind of just like check it yourself too. 3 minus 1 is 2. 2 squared is 4. 4 times 3 is 12. But put it all in the calculator and you can avoid like making a silly mistake. All right, then transfer that onto your graph. The negative 112 doesn't fit, so can't really put that one on there. But the 0, 3 does. So that goes there. The 1, 0 goes here. The 2, 3 goes here. And 3, 12 again doesn't fit. It'd be like somewhere up there. But draw your U shape. And unless it says otherwise, it goes on infinitely, either up or down. Okay? Domain for this is always going to be what? Purple. Good, at least for these U shapes, yes, it will always be all real numbers. The domain is all the x's. It will eventually go left and right. What about my range? Does it go infinitely up and down? Where does it look like it stops at? Looks like it goes below the 1. Looks like it stops here. And that should match the y value of my vertex. Because by definition, vertex is your highest or lowest point. So that should match for the y where it stops. Would you say that these y values, and you can look at either the table or the line, would you say that these are greater or less than 0? So then the opening should be facing the y. Does it touch the 0? So then put that little line underneath, because it can also equal 0. Questions on that? Okay. I feel like it'd be a good time to work on the practice. Let me look at the back real quick. Or actually, yeah, because the rest are transformations, and that will take probably another day. So, I'm going to pass out your practice. It's not part of your notes. It looks different. It's going to look like this. All right, and all you'll be able to do for right now is this part. You should not be able to do the transformations yet. We'll talk about those tomorrow. You should be able to do that part and the table and the graph. I'm going to pass it out now.